Okay, the fifth lesson of Algebra 2, Unit 1, Part A is composition of functions. I'm going to give you a definition and then we're going to go through about 4 examples of what composition of functions are. So the composition of functions is applying one function to the results of another function. Now you may read that and say, I really don't know what you're talking about, but I think once you take a look at the examples, you'll understand. So really that's the mathematical definition of that. So let's go through a couple of examples. So we're gonna, like we did with functional notation, I'm gonna give you several functions. Let's zoom out a little bit, okay. So I'm gonna give you 3 functions. H of x is 3x plus 3. G of x is negative 7x plus 1. And h of x, actually let's make this an f. F of x is equal to six. Okay, so those are our 3 functions. So in example number 1, we're going to find g plus h of x. Now all this means is we're going to take the g function, g of x, and then add the h function. Now I'm writing it like this just to show you. You don't necessarily have to write it out again. I'm just showing you we're going to take this g function and then add the h function. So I'm going to keep it in parentheses. You don't necessarily have to. That's just something that I get into the habit of doing. So this is my g of x, negative 7x plus 1. My h of x is 3x plus 3. And then I'm just combining like terms. I would be looking out in front to see if I have to distribute, but I don't see a number there. So let's just combine like terms. I've got negative 7x plus 3x, which gives us a negative 4x. Here's my other set of like terms, 1 plus 3, that's giving us 4. So negative 4x plus 4. Okay, let's take a look at example 2. So example 2, we're going to do h minus g of x. And again, I'm going to rewrite this just to separate it. I'm going to say h of x minus g of x. You don't necessarily have to rewrite it. I'm just doing it to show you. So let's start off with the h function. That comes first. Well, my h function is 3x plus 3. So that's what I'm going to write. I'm going to keep it in parentheses because it's an entire expression. I don't want to separate it. Minus g of x. Well, my g of x is negative 7x plus 1. Now, there's a couple of ways you can do this. You can take this negative and distribute, or you can just subtract like terms. So it's really up to you. I think it's easier just to subtract like terms. You got to be careful. 3 minus a negative 7. So 3 minus a negative 7 makes that plus a positive, so that's 10x. Or 3 minus 1, well, and 3 minus 1, that's giving us 2. So 10x plus 2. I think I'll show you how to do it the other way, and then you can decide how you want to do it. So if I take this negative, I'm going to rewrite it, just to show you. If I take that negative and distribute through, I'm really distributing through a negative 1. So this becomes 3x plus 3, and then this changes to plus. 7x, negative 1 times 1 is a negative 1. I'm going to combine like terms. That's giving us 10x, and then 3 minus 1 is 2. So it's up to you how you want to do that. You can keep it as is and just subtract like terms, or distribute through a negative 1 and then combine like terms. Okay, let's take a look at example number 3. I've got 2 times f of x plus 4 times g of x. Actually, let's kind of change this. Let's make that h of x. That's better. So let's do 2 times h of x plus 4 times g of x. So I'm going to take, this is 2 times. So I'm going to put parentheses here to show multiplication, and I'm going to write the h of x function, which is 3x plus 3. I'm always going back to the original 3 functions. That's what I'm referring to for all of these problems. And then plus 4 times g of x, which is negative 7x plus 1. This is times. So now I've got a number times parentheses. That means we're going to distribute. So let's go through and distribute. 2 times 3x is 6x. 2 times 3 is 6. I'm going to take this 4 and multiply through. 4 times negative 7 is negative 28x. 4 times 1 is 4. And then from here, we're just going to combine like terms. That's always the procedure. Distribute, combine like terms if you can. You're not solving for x, we're just simplifying. So I've got negative 22x when I combine 6x minus 28x. And then 6 plus 4, that's giving us 10. Don't try to solve here. Your answer is going to have a variable in it, and that's okay. It doesn't have to be a number. It can be an expression. All right, let's take a look at one final problem. Number 4. So number 4, let's do, actually I think I'm going to, because I'm going to run out of space, let's go up here. So number 4, we've got h of g of x. So here's what I'm going to do. This is not a multiplication dot. This means h of g of x. So I'm going to replace, remember you work from the inside out, so this g of x, I'm going to take this negative 7x plus 1 and put it, and just replace it. Now, I'm going to take the h function. You're not distributing. This is not a number. It's a function of a function. So it's done slightly different. So I'm going to take that h function, which is positive 3x plus 3. That's what that h function is. Now I'm going to take this entire thing, the entire expression, and put it in for x. So I've got 3 times negative 7x plus 1 plus 3. 3 times negative 7x is negative 21x. 3 times 1 is 3, and then I'm going to bring down that plus 3. And then I'm going to combine like terms here. Don't solve for x, we're just combining like terms. Don't minus 6, add 21. You're not solving for x, you're just simplifying. So it's negative 21x plus 6. And that is the end of lesson 5.